6.3 gravitational potential energy. So let's go over work done by gravity. And simply put, work done by gravity, all you do is replace the acceleration with gravity here. And then we have to denote that a downward sign convention is either positive or negative. Usually I'll say negative, but we'll get to that later. As a result, the work of gravity is simply the force times d times cosine theta, which the force here would just be the force of gravity, which will be m times g cosine theta. So negative work can also be done if the item is moving upwards. So theoretically, it would be negative mg cosine theta displacement. And if the displacement is upwards, then that means we have a negative displacement because it's going in the opposite direction. So let's define gravitational potential energy. Work by constant forces, work equals force times distance times cosine theta. For gravity, force equals mass times gravity. Displacement equals yf minus yi, which is just the change in position. Sorry, I'm talking kind of fast because I'm kind of big. So if upwards is positive, then the work is equal to negative g. And I think I forgot an m here, actually, because that would be force. So it would be negative mg yf minus yi. And the reason is if the yf is higher, then it's negative displacement here, because that would be a positive term. If yf is slightly higher than yi, which is negative because gravity downwards would be the positive convention. So gravitational potential energy is defined as mgy. And that's basically how it was defined. Y equals mgy final, mgy initial, which is the same exact thing as the kinetic energy thing. And then we could set that equal to this if we want to calculate final and initial velocity. So that's all it is.